CPM Math 3, Problem 1-81. We're being asked to calculate an interquartile range. And for some of you, this may be the very first time you have actually heard that word. And that is okay, because it's actually fairly easy. There is a math notes box in your textbook with this section that you can read. There's also a Khan Academy video linked in your resources page. That is just excellent. And like I said, it's very easy. The first thing you have to do is find the median. And thankfully, our data is already ranked from least to greatest. So 4 and then 5, 5.8, and it's not all scrambled so that we have to put the numbers and the data points in order from least to greatest. But then we do need to find the center, the median of our data, which means we have the same number of data pieces to the left of our center and the same number of data pieces to the right of our center. And so we have 1, 2, I believe we have 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data pieces. So that means I'm going to have 5 data pieces to the left. 1, 2, 3, 4, 5. That's the left half of the data. And 5 data pieces to the right. 1, 2, 3, 4, 5. And this little fella is our median. Okay, so that's the start. We have to get the median. Then we have to look at the left side of the data and the right side of the data and find the median of those two pieces. We ignore the median in this case as we're continuing with our calculation, and I'm only going to focus on this left half and imagine that being separate. So I have 5 data pieces and I need the center of that data, which happens to be 5.8, because now I have 2 data pieces on the left and 2 data pieces on the right of this little guy. Okay, now I go to the right side and I pick the center or median of the right half of the data. So all I'm looking at are these 5 data points, again, kind of ignoring that median and everything over here, and I find the median or center point or center piece of data, which in this case is 8.4. Now I have 2 data points to the left and I have 2 data points to the right. So I actually have identified 3 data pieces at this point. And coincidentally, these do have names. This is actually called quartile 1, which we abbreviate with a Q1, and this guy actually is called quartile 3. And the interquartile range comes from subtracting quartile 3 minus quartile 1. So our interquartile range is 8.4, this guy, minus 5.8, this guy, which equals 2.6. So our interquartile range, abbreviated as IQR, is 2.6. Again, that might be new for some of you. We are also being asked to complete a box plot of this data. And in a box plot, you just create a number line that you know is going to hold all of the data pieces. So I kind of started one by going from 0 to 15 here, because I know it's going to make sure to be able to hold anywhere from 4 to 12. From this point, all we do is plot 5 important pieces of data on the number line. We plot the lowest point, data point, the highest data point, and then the 3 data points that we calculated, the 5.8, the 8.1, and the 8.4. And so let's go ahead and plot those and see what this looks like. All right, so these are approximations. I plotted the 4 right here, the 5.8, the 8.1, the 8.4, and the 12. Now, that doesn't mean a whole lot right now, but what we do is we take the center 3, this is a lot, I know, probably coming at you, and we draw a line through them like this and draw the actual box around it, and then we draw the lines or the whiskers extending from the box. And people use this to sort of kind of tell where data points are concentrated. Because we know that there are the same number of data points in this little section right here as there are in this section right here, that's actually very revealing that, you know, maybe these are scores on a quiz, that a lot of people got their scores on a quiz between 8.1 and 8.4 points, so to speak, as a maybe. Oh, no, this is earthworms. There's a lot of earthworms that are between 8.1 and 8.4. It also tells us how far maybe an outlier might be. This 12 might be an outlier, or you may have a couple of outliers because that whisker is so terribly long. All right, so this is our box plot of our data. We will be doing more. Make sure you study up on this and maybe watch that Khan Academy video.